All right. Hello, everyone. Welcome to my presentation, where I will show you how to model the domain in the code using Kotlin. So this is clean, concise, and easy to understand. I hope you enjoyed the lunch and you are full of energy, so I can smuggle some Kotlin code into your minds during this presentation. But let's see what this presentation will be about. I need to tell you something. I'm not a fanboy of any one programming language, whether this is Java or Kotlin or any other one. However, if it comes to Kotlin, I really believe that this is a great choice if you need to implement some backend service or backend system with rich domain model for some complex business logic. Why do I think so? Because Kotlin provides, Kotlin is full of the nice feature, including functional ones, that allows you to write the code which is highly readable and concise. Yes, nowadays, we mainly read the code. There is the parallel presentations on reading the code. So this also means that this topic is important. And we also use a lot of LLMs to generate the code. So yes, we read this code even more nowadays. The code which is aligned with the business language. So in other words, the code which speaks the business terms. This is also important because this allows you to map the business requirement to your code and other way around. And it also allows you to better communicate with the business on the requirements level. The code which is less error prone, easy to test, resilient to the requirement changes. This is also important. We know that businesses, they like to change the way how they operate. So it is also good that the code and the model is easily adaptable to these changes. And yes, sometimes we want to have some fun from implementing those features, those business requirements. So why not? And as you can see, I have no slides, so it will be, all the presentation will be in IntelliJ. It will be the live refactoring. Most of the examples will be live coding. For some, I will do some shortcuts because of the time restrictions. And during these presentations, I will transfer some, let's call them anemic code, into something more readable, more idiomatic and efficient Kotlin code using its features. And if you have any questions for these presentations, you can use the Slido. Go to wall.sly.do, use the code GeeCON, and choose room number 10. There is also a poll, so we can rate these presentations as well as another ones. Okay, a few words about me. My name is Rafał. I am a staff software engineer at Software Mill. I code mainly in Kotlin and Java. In Software Mill, I'm also responsible for Kotlin department, and yes, I like filter shortcuts, which are very common in our industry, like TDD, DDD, and others. Okay, before we will jump to the code, let me briefly introduce you to the domain that this code will operate. This will be a very basic e-commerce platform with very simplified functionalities like user registration, order creation and management. There will be some export functionality of the orders to the Excel file. And yes, because this is e-commerce, we need to count money, so there will be some operations on money. Okay, so let's go to this user registration functionality. So as you can see, I prepared the model of user here using the data class. Data class, if you know how it works, this is like a record in Java, so this is basically some bucket for the data, and under the hood you have the equals hash code and some constructor generated for you. And yes, for now, this is modeled this way that it has the first name, last name, and email as the string types. And we have also also the age field, which is the integer. We have the object, user registration. Object is the class which has only one instance in the runtime. So this is basically the singleton, but you don't need to use the frameworks for that. And there is only one function, register user, that takes our user model, returns Boolean, and basically it registers the user. So we have some email address validation for this user. We just check the records, this is simplified. And in case if, this user email is incorrect, we throw exception. We also have the age validation, so user must be older than 18 and younger than 100. In case of this validation failure, we also throw exception. Then we try to persist this user in some in-memory repository. And this is also simplified. If it works, we return true. If there is some exceptions during this persisting, we return false. Okay, and this code, yes, this is simple, this works, and this is quite readable. However, I would like to show you some refactorings that we can execute here. Before I will do that, I will also show you that, of course, we have the tests. here. So we check whether we can successfully register the user, if the email address and age is valid, whether there is the exception in case of the invalid email address. We also validate there are exceptions when the user is younger than 18 or older than 100, and we check the use case with persistence failure. Let's check whether those tests pass. Okay, it's green, which is good. So the first thing that I would like to improve, slightly improve, is this email validation. This is fine. However, I can imagine that in the e-commerce platform, there are other places in the code which require the email validation, right? And yes, you could say that we can create a service like, I don't know, email validation service or something like that and reuse it in the system. I would like to propose the other approach. And for that, I will create the new class. I will call it email. Okay, and this class, it won't be the data class or just the class in Kotlin, but it will be the value class. Value class is the type of the class which is inline in the runtime. So this only provides some context for us as the developers, and it takes the single type here, single field that it encapsulates. In our case, it will be string. And value class, as I said, is inline, and unfortunately, the JVM requires the JVM inline notations to inline it runtime. So what we want to do here in the init block, we want to validate whether this email is correct. We will use the same way how we do it here. So I will copy this regexp. So if this email, does not match our regexp, we want to throw invalid email address exception. So, and of course, pass this email here. So yeah, the validation is the same. What we did, we encapsulated this logic into this value class called email. So coming back to our user, now I don't want to have this email like the string, but I want to replace it with our value class email. So looking at this model, we see that this email is not just any string anymore, and we don't need to validate it in our registration function. So I can actually remove this code here. And we see the context, right, of the string, and it clearly says and express the reason why this string is here. And of course, we've got the validation. So going to our tests, we see that they don't compile because, of course, the user requires email now. So I will wrap it with the email for all of the tests. Okay. If we run it, yes, one test fails. Why? Because this test expects that there is some exception thrown by registered user, but we moved this logic to the email. So actually, currently it's not possible to create the user with incorrect email because it requires this value class. So the exception is thrown here. For me, this test doesn't make sense anymore in the user registration test. Of course, in the real project, we would implement this test in the email for the email. But yeah, for the sake of the presentations, I will skip it. And of course, now the test should pass. Okay, so that was the first thing that we did to our model and to our register user function. The second thing is this user's age validation. So yeah, this is fine, right? We can see that user must be older than 18 and younger than 100. However, I would like to show you another way that we can do it in Kotlin to have this expression even more expressive. So we want to say that the user age, and we will use not in operator. So user age should not be in 11 to 100, right? So I think that you see this is closer to the natural language. So yeah, it clearly says user age. So if user age is not in the range of 18 to 100, then we throw the exception. If we go to the test, nothing changed if it comes to the code. So yeah, it compiles, the tests pass, so this is good. The second thing I would like to improve here is this return type. So we see that this is Boolean, but reading this code, we know this is not really the true, that it only returns true or false, because we have the third state, which is the some exception, user age not valid exception, which we throw in case of the user age is invalid. So I would like to also refactor it, and for that I want to use the Kotlin result function. So result function, the result class. The result class is something which has like two states. There is the success or failures. In success, we need to provide the type that we want to return in case of the success, and for that we will use we'll create the value class user ID that will wrap some user ID which is uit. I need to add file here. Okay, and again, we need to add the JVM inline annotation. And we want to say that this result, in case of the success, is of type user ID. In case of the failure, the result will hold some exception. Okay, this is similar concept to either that you can know from other languages. And instead of throwing exceptions right now, we want to explicitly say this result. So in case of user age is invalid, we want to return result of type failure and provide our exception, which was user age not valid exception. Okay, I will import it so to make it shorter, so there are less character to read. And in case of the success, we want to return result of type success, and we want to provide this user ID object here. So for that, we can check that there is the UIT returned from here, so we can use it. And we'll wrap it with our value class, providing this user ID. Okay, and I will also import it here. And in case of the exceptions while persisting the user, we want to also return failure and provide, for this failure, provide this exception which was thrown by the persisting layer. Okay, if we go to the tests, okay, they compile, which is maybe good or maybe not. Let's run them. Okay, they fail because, yes, we expected that this function returned true. However, currently it returns some result, right? So we need to change this code. So instead of checking whether it returns true, we need to check whether the actual result is success. So whether is success field is true. For age validations, we don't want to check the exception anymore, but we want to check whether the result is failure. Should be true. The same for the test for older user, and the same in case of the persistence failure. Okay, I run the tests. Okay, they pass. And this is good because it allows us on the client side to hand the results like explicitly. We don't need to guess or read the code or read the documentation that there is the third state, a part of the true and false, which is the exception. So we know there is always the result, and we know we need to handle both failure and success. However, let's imagine that there is more failures possible in our code. For example, we want to check whether the user is not duplicated in our code, in our e-commerce. So for that, I will add some methods here that will exist, that will take our user. It will return Boolean, and yes, return user contains, so return true if there is some user already registered, or false if the user is not registered. And we will use this in our user registration function. So if user repository exists, so if our user exists, then we want to, I will keep it like this. We want to have some failure. And of course, we could use the result again and provide the other exception here. But I want to show you the other solutions which I use quite often. And these solutions, it use the sealed class to model like explicitly the infinite state of all the results that can be returned from our business logic. Okay, so for that, I will declare the sealed class. We'll call it user registration result. And the sealed class is the class which have the finite list of the inheritors, and all of them, they need to be defined in the same file. And what it helps us with, it allows us to use the exhaustive when operator on the client side. So where we hand this result. And yes, we want to have like two types of the result. The first will be success. Let's call it user registered, and we want to have our user ID here in this result. My typing is very bad. And of course, it needs to inherits the user registration result, and our other type will be the failure. And for that, we will decline the type or the class failure. No exception, no here. And yes, it also inherits the user registration result, but we want to specify the exact types of this failures. So our first failure is user age not valid. So we will use the object user age not valid, which is of type failure. We will have the other user object user order exists, which is also the failure, and we will have the data class for error while persisting user, which will take some exception, and it is also of type of failure, persisting user. Okay, so I defined the hierarchy of the possible results from our register function using the sealed class. So we have like two types, user registered and failure, and we have the specific failure types. So now in our register user, we don't want to use the result, the Kotlin results anymore, but we want to return our user registration result from this. And in case of the user age validation, we want to return this dedicated type, which is user age not valid. Okay, in case the user exists, we want to return user already exists. Okay, and add import. In case of if user was registered successfully, we want to return user registered, and also we provide the user ID as the argument of this class. Yes, let's short it. And for this, we want to return error while persisting user with our exception returned from the persistence layer. Okay. Oh, this should be user registration result, not any. Okay. And let's go to our test now. Of course, they don't compile because there is no success anymore here because we changed the Kotlin results to our custom results. So what we want to check here in our test right now is where the type of this registration result which is returned from this function. So for that, we will use the method should be instance of, and in case of the success, we expect type user registered. Okay. In case of user age validation error, we expect user age not valid. Same for other case when the user is too old. And in case of this, we want error while persisting user. Okay, let's run them. Yep, so one test fails, and this is because we use the same email here, and just to remind, we added this validation for the already registered user. So in that test, I will change this image so it should pass. And yes, I will also add the test here that should not register user if already exists. So what we can do is, reuse this and try to register the user John Doe 2 first time, and for the second time there should be user already exists. Okay, the test passed, which is good. So that was all. Oh, sorry. That was all for our user model. So just to wrap up, we executed a few of refactorings here. So first thing, we changed this string for email to the value class, which gives us the context of this string. This is the value class. So in the runtime, it is inline, but this is only for us to know the context. And under the hood, we have the validation of this email address. Then we also changed the conditions for the validation of the age to use the not in operator with range operator. We also changed the return type from Boolean first to the Kotlin results, and now this is the user registration result, which is our custom result. Okay, the second thing I wanted to show you is the order creation or the order model. And for that, in our e-commerce, we have the data class called order, which has a few fields. So the order ID, the user ID that this order belongs to, and some status here. Let's jump into the status, and there are some business requirements that the status of the order can be pending. So yeah, the order has been created, and the user can add some items to this order. The order can be completed. So in that case, the total amount of the order is calculated, and since that items cannot be added to this order anymore, the order can be shipped to the buyer. So some shipping address is added to the order and cancelled. Of course, yeah, this is very simplified, but just to show this model and how we can improve it. And just as you can see, a part of the status, we have also items, which is the list of some order item. It has product ID, some quantity of those items, and the price. It has total amount, and as you can see, this uses the question mark at the end, meaning that this is the nullable double, meaning yeah, it can be null. Why? Because yeah, we have the one model for all the states, right? And we know already from the requirements, from the business requirements, that the total amount and also shipping address, they are only valid in some specific status. So let's say when the status of order is pending, the total amount is null because yeah, we just calculate it when the order is completed. And yes, then for shipping address, we add it only when the order is in state shipped. Okay, and we have a couple of business operations here. The first one is cancel order. And yeah, according to the business, we can only cancel the order when this is pending or completed, right? So we need to check before actually executing this code, before changing the status to canceled, whether the status of this order is pending or completed. So yeah, we use the check. It basically takes some condition and yeah, throws exception if it is not met. So we check that the status should be pending or completed, and if it is not, some exception is thrown. If it is, then we just change the status to cancelled. Same for the add order item. We check whether the status is pending, and only if this is pending, we add the orders to the item. For get order total amount, we need to use the Elvis operator because we know the total amount could be null. And yep, business required that in case it is pending, we just return 0. For completed order, the same story. We need to check the status of this order, and only then we can change it to completed, calculate the total amount, and so on. The same for ship order. So as you can see, because of the way how this order is modeled, there is a lot of like the noise, some ceremony in those functions that requires us to check the status, some internals of this order before we can actually execute this operation. My colleague called this model schizophrenic model because it may have like multiple states and it behaves differently depending on the states. I will also show you the test for this, which is also not really good. But okay, let's look into the test for the canceling order. So we know that we can cancel the order only when this is pending or completed. So we check that for pending, yeah, it was cancelled. For completed, it was cancelled. But for shipped and cancelled, we need to check whether the exception is thrown, right? So again, there is some noise because of the way how this order is modeled in our code. Same for adding item to order. We check whether this is whether for pending order it works. So we can add some items there, but for completed, shipped, and cancel, we need to check whether the exception is thrown. What I want to show you, to propose how we can change or improve this model, is to use again the sealed classes to model the suitable states, the business states. For that, I will jump to the order repository, to the order branch, because there is quite a lot of code to change. But no worries, I will try to explain everything here. So this is our order again, and as you can see, it's not data class anymore, but this is the sealed class. Again, the sealed class, yeah, it may have like the finite list of the inheritors, and they must be defined in the same file. And in this model, the order has only ID, the user ID, and the items. So there is no total amount, no shipping address anymore here. And no status, right? Because the status of the order are modeled by the inheritors, by the subclasses of this order. So we have pending order, we have completed order, we have shipped order, and we have cancelled order. Okay? And we also have the interface cancelable order. So yeah, we can. So for example, in our pending order, we can use this interface and to mark this state of the order that it is possible to cancel it. So let's review the pending order. It has the same set of the fields, so only order ID, user ID, and the items. And now, for example, in the complete order function, we don't have checking the state anymore because there is no the state. So there is we know that this is run, or this code, this operation is valid only in the pending order context. So we don't need to check the status anymore, which is good. So we got rid of some noise, of some ceremony in the code. Same for cancel order, right? We don't need to check the status here because this is on pending order only. And yeah, actually, currently the compiler guarantees that that we can run this function only on the correct business states of the order. Yes, same case for the completed order, but here we also have the total amount, and this is not nullable anymore because yeah. The total amount is always calculated according to the business rules in this state. And also this is simplified, so actually we could get rid of it and just use the total amount field. And yes, in this method, in these functions, we don't need to check the states anymore. And same for ship order. A part of total amount, we also added shipping address, which user need to provide in order for this order to be shipped. And how it changed our tests. So they were also simplified, of course. There is less lines here, and yeah, we got rid of the noise of checking the invalid business states of the order here, because again, right now the compiler is responsible of checking those states because we modeled them by the subclasses of our sealed class. So for example, for canceling order, we only need to check whether we can cancel a pending order, and it should work, or whether we could cancel a completed order. So we don't have the tests for the other types, other status of the order anymore. For completing order, yeah, we only check whether we can complete, whether completing the order with non-empty items works. And the other test is just to check whether it fails for the order with empty items. We don't need to check whether it fails for the orders with incorrect state. And the same for other states. So yeah, it was also simplified. Okay, so I hope that you got the idea. And the other thing that I would like to show you is some syntactic sugar actually. So as you can see, while creating those pending orders, or other orders like completed order and others, we in our test we always have to provide this order ID, user ID, and other stuff, which in all the places this is just random UID. So there is some mechanism in Kotlin that allows us to provide some default value for the constructor arguments and also for the function arguments. So of course we shouldn't use the random UID for the production code, but yeah, for the sake of this presentation, let's do it. Or maybe sometimes it's valid, who knows. And yes, so I defined that for the pending order constructor, when the order ID and user ID is not provided while calling this constructor, there is some default value, which is the random UID, provided for those fields. So thanks of that, we can get rid of those lines, because yeah, this is the default argument, and we know that this will be the random UID. So we can get rid of some lines here, so it is shorter, easier to read, yeah, easier to understand, and so on. And you can use it for both constructors and the functions. Okay, let's go to another thing in our e-commerce, which is the order reporting. So this is basically some exporting function that allows us to export the orders to Excel file. So there is the function create report for orders. It takes the set of our orders, and it uses, as you can see, Apache POI to create some order reports, Excel file with the sheet order reports. It has some columns. They are not important. The one that I would like to focus on is column with index 6, order representation. Let's keep it because as I said, this is not important. Let's focus on this part of the code. So the column for the values for the column with index 6. So we have some order representation here, which is the string, basically, multi-line string. It has some order ID created by, taken from our order. And below there is some table with our items which are added to the order. So this is something similar that we see on the invoices usually. So yeah, the columns are item, quantity, price, and total. And yeah, let's assume that there is some business requirements that we need to print it in the Excel. However, I may expect that in the e-commerce there are the other contexts or the other places in the code that we also need to use this representation. For example, in the invoice, for example, whatever. So it's probably good to somehow extract the creation of the string from the order. And what we can do, of course, is that we can add this function here, right? So declare the function to order representation. Let's call it here. It returns string. And yes, we just add it here. This order we need to change to this because yes, we took those fields from order. And yeah, it should also work. We can reuse it. But yeah, again, it introduces some noise, right, to our code. Because for the order, let's say this is our model, we don't want to harm it with some code from another context. We don't really need it, but we only would add it to have it available in other places in our system. So in Kotlin, we can do it even better. So we can come back to this order reporting, and there is the nice feature called extension function. Extension function is the concept that allows us to declare and implement some function on some object that we have access to. For example, we are not in order here, we're in order reporting, but we can declare our toRepresentation function or toOrder representation function on our order. It returns string. Yes, and we just return the string. So using this function extension mechanism, we just extended our order with these functions, and now we can execute this. We can call this function on our order from this place, which is quite natural, right? This is because we declared this as part of this class. However, it is also possible to declare our extension function on the file level, so it would be available in the other classes as well. So let's say we may have some class, so the order representation creator or something like that, and have this extension function that we can use in other places. Yeah, for the purpose of this order reporting, we can keep it here. We can also make it private, probably. And yes, you can. This is also useful when you want to add some functions to the classes that you cannot modify. So, for example, when you use some library, right, and you have some class there, and you want to have a nice, let's say, DSL or something, and extend this class with some function without touching it, without actually extending it with this code. For example, we can also extend our string, right? The string from Kotlin. Let's say with function GeeCON, and we'll return string. GeeCON is the best. And this is also fine. Now we can execute this, for example, here. And it works. And yes, I usually use it for building some more expressive codes, let's say the DSL. So instead of yeah, doing it like this, like we did it here. So inlining some string or something, we can use the extension function to make the code even more expressive. Okay. Now let's go to the money thing, the e-commerce. So we have the money. This is probably far from the perfect because this is double. It is double, but this is not the subject of this presentation. So yeah, so we have the money class, and it has some amount in the currency. And according to the business rules, we have the two operations there, which is the add, and we can only add the money with the same currency. So as you can see, we check whether this currency and other currency is the same. If not, yeah, this check will throw some exception. And if the currency is the same, we just return the new instance of money with the sum of the amount and the same currency. We can also multiply this money with some factor, let's say, I don't know, to calculate some discount or the tax or whatever. So we have the multiply function for this. And yeah, there are three currencies currently supported: PLN, USD, and Euro, Polish zloty. And yeah, that is good. We have also the test for this money class. So yeah, we can add money in the same currency and it should work. We should throw exception when adding money with different currency. So we expect some illegal state exception here. And we can apply discount to money, let's say. So we have some money, we multiply it with some factor, and yeah, it should be calculated here. As I said, this is nice. However, I would like to show you the nice feature, which is also available in Kotlin, and this is possibility to extend the operator. And for that, we have the defined list of the functions name that we can, or the operators that we can actually override. And let's say that we want, for add, of course, we need to add the plus operator, and for multiply, we need to use the times operator, which is the star character, and for plus, of course, this is plus. And yes, coming back to our tests. So we have no add functions anymore here. So what we can do, we can use the plus method with the dot and parentheses, but we can also change it to the plus character. So yeah, this is even closer to the natural language. It's shorter. It's easier to read it and reason about what it does. Also for this test, we can also change it to money too. And for multiply, we could call it times, right? But we can do it even better with the star character. Okay? Drink some water. The last thing I would like to show you in our e-commerce is the integration tests that we have here. Yep. This is the real production code, so we have the tests. And we have one test case here, should create user and order. And as you can see, we have some given section. So given user is registered, and we try to register some user. Here, we call our registration function. We check the results here. We expect that this is success, right? And in case of other status, other result returned from this function, we just throw the assertion error. And this is the exhaustive when operator usage that I told you. So thanks of having this sealed class here, compiler will force us to handle all the possible states. Of course, for the states, we can use else. So for other status that is registered, we just throw some assertion error because this is the test only. So we register our user. Then we create the order in the pending state with some random with the user ID that we created, and the items list is empty. We add some items to this order, yeah, some things with quantity 2 and price 50, and the order with 100, quantity 1. Then we complete this order. So yeah, according to our business rule, we expect that the instance of this order will be completed, and the total amount should be 200, right? So this is quite simple test. So it is quite easy to read. However, I see quite a lot of noise here. First of all, this user registration, right? It is I don't know, 1, 2, 3, 4, 5 lines, and there are some internals here, like calling suitable method, then handling the results. So at least for me, there is quite noise here. Also for creating the order and adding the items, imagine we have like the bigger test, more items, more orders, so there will be quite a lot of lines of the code in order to test it. And then in assertions, it's not really bad, but we have 2 lines here to check the business, the expected observable behavior for our business operations. Do you remember the promise of BDD that you can write the test, or actually the non-tech non-techs can write the test, like PO or PMs can write the BDD test, and yeah, it will work. Of course, it doesn't work, but at least I like to have the test in our code, in my code, that I can sit with my colleague, which is the developer, with some non-tech guy, and just go through it and discuss the business requirements or the changes in the business requirements. And for me, that's code. Even this is very simple case. It's not really good to do it, because again, it has some ceremony here to to check these results and some noise. What I would like to propose here, I will again jump to another branch. Okay. Oh my God. Nope. Wrong branch. Sorry. Okay, it works. So what I would like to show you is using the DSLs, which I very often use for my integration tests, but also sometimes for the unit tests. So this is the same test, but it uses the mentioned DSLs. So first, in the given section, I register the user. So there is no more this noise of creating the user, checking the status, but it has some nice function, register user. It takes some properties of this user, and at the end, we say that, okay, for this user registration, we expect success. I will go to the details of those functions later, so we'll see how it works. Then we have the order section, and we just create the order. Again, it's not like the multiple lines here. We just have the one functions that create the order. We provide the order creators, the items for this order, and that's all. And we have the when merged with the assertions, with the then section. So we execute the complete order on our order and have some nice method should be completed with total amount that under the hood checks whether this completed order is really completed and whether the total amount is correct. So at least for me, it looks better, even if this is very simple scenario. So I could sit with someone else and discuss the business requirements based on this code, because there is a lot of noises here related to some let's say code ceremony here. And how does it work under the hood? So yeah, it uses the aforementioned concepts like value classes, like extension functions, and it also uses the higher order functions. So for example, this register user, it is the functions that take the order functions. There is some builder here. So in this builder, we just create our user, we call our user register functionality, and of course we return our user registration result. I will not jump into the details of those DSLs because, to be honest, nowadays I don't write them by myself, because there is quite a lot of repetitive code here, something that is not really useful to write by hand. So what I usually do right now is I just write the DSL that I would like to have in my code, like this. I put it to ChatGPT or Sonnet or other AI, and also provide our model. So in our case, let's say user and how the user registration works, and ask to generate all the stuff. Yeah. So all those methods, they were generated by let's say ChatGPT, and I also recommend you not to do it by hand, because again, this is a lot of repetitive thing to do, which doesn't provide some business value. The one thing that I would like to explain and show here is this function, because this is something probably new in this presentation. So as you can see, there is no dot here, and there is no parenthesis for the arguments. Of course, it could work this way, but because we use some nice concept, which is the infix function. We could skip both dot and parentheses. And the infix functions you can use with the extension functions that has only one field here, because of the because we may have only one argument, right, without using the parentheses. And thanks of that, we could skip again the dots and parentheses, and all the operations that I expected in the assertion. So checking whether the status of this order is completed and checking whether the total amount is expected amount. Yeah, it's all wrapped by this infix function. Okay. So that was all for this presentation. Okay. So to wrap up, we've done a few refactorings for our e-commerce platform, changing, let's say, anemic structure to something more expressive, something more, let's say, domain-driven, using Kotlin features like value classes. So we applied it to model the email. Again, value classes is something that is inline in the runtime, so it is only for us for the expressiveness. The range operator, yeah, we changed the regular condition using the less and or operators to using range operators and not int operator. Also, we use the result class to model the return from our register user functions. Then we change it to our hierarchy of the results modeled by shield classes. I also showed how default arguments works and how extension functions works in Kotlin. We use the operation overloading for money operations, and at the end there was an example with the DSL for the integration tests. And I think that's we have 3 minutes for the questions, if there are any. Can we get exception message or just exception type from built-in control user failure in test to compare it? Yes, I skip it, so I just check whether the result is failure. But yeah, in let's say real codes, we could also check the message of the exception. When providing result failure, can we use some object that is not exception? No, in result, yeah, it always requires the exception. Yes, so we could create the either for this, or use the either from, I don't know, from arrow, let's say, a library. Are hierarchies of registration lizard zero cost? How does it look like allocation-wise? Of course, there is no free lunch, so yes. To be honest, I don't know the details. I don't want to discuss it right now how it is, allocation-wise. But I would say that there is no free lunch. Again, there is no free lunch, so for sure there is some cost of using it. However, there is always the questions: what is our driver, right? Whether we want to optimize for the performance, or whether we want to optimize for the readability of the code. In my case, it's usually readability of the code, because yeah, this is the context of the software development that I works, which is the business applications usually. Result T, where's the improvement if you still need to create an extensive stack trace? This is mainly for the readability for me, again, and for the handling it by the client side. So there is no exception, which is our third state for the Boolean anymore, but we are kind of forced to handle the both states, or we are forced to have only two states and also to handle two states on the client side by using the result. Infix, any other advantage of using it instead of only reducing few characters in code base? This is something I'm not aware, sorry, but yeah, I always only use it just to reduce a few characters, and yeah, again, make the code more readable. Does the shield classes are backed by Java shield classes, or it is sometimes distinct Kotlin mechanism? Yes, this is the Kotlin specific mechanism. As far as I know, they don't use the Java shield classes. In user model, why not to wrap and validate the age similarity to email? Of course, we can do it, and most probably I would do it. I just wanted to use it, make it faster, and just show you this not in and range operator. Most probably in the real code, I would do it this way. Because yes, we left some other strings and the integer in the model, but for the sake of presentations, I skipped it. What are your thoughts on using run catching for methods returning result? So I've got the method returning a result, and I wrap it in run catching. If I'm not sure if I got it correctly, or this is about running. Okay, so yes, the run catching is something is like the try a catch block, but I can wrap some code, and yeah, I have the result that I need to handle. I usually use run catching, maybe not usually. Sometimes I use run catching when there is some, let's say, finite state of the result, but not sure whether this is about this case or this is about wrapping the run catching with some methods that return results already. So if we can talk about it later, you can come to me and we can discuss it. I can imagine it is used somewhere else, a solid approach. Should we first make sure that there are enough use cases to follow the pattern? Of course, yes, this is just for the sake of the presentation. So we should always take care, check whether it really makes sense to do it. Aren't extension function dangerous in terms of internal extended object consistency? This can mutate the object state to some invalid state. No, it cannot mutate the state of the object, so yeah, I don't think this is dangerous. What if validations are different for 20 different use cases? Do you also keep them in model, and how do you model validations that need DB or REST calls? So I would say it depends, right? So yeah, sometimes it makes sense to have like the separate code to make the validations. I don't know, some do it on the DTO level. Sometimes it makes sense to keep in the model. So yeah, I would need some more context to answer these questions. Sorry, but it depends. But if this is like the domain code, I try to keep the validation as close as possible to this model. Thanks for the attention. Kotlin is the best. I also like Kotlin. Yeah, but as I said, I'm not the fanboy, but I know a few. I think that's all. So thank you very much. I hope you liked it, and see you later. If you have any more questions, I will be around so we can discuss it.